In this video, we are going to talk about sine and cosine functions. We call sine and cosine functions, all these graphs, we call them as sinusoidal relationships. These are the relationships that they have a curve which resembles a sine curve. Now, in real life situation, there are so many patterns out there which, if you graph it, it's going to resemble either sine or cosine functions. One of these patterns is with the electricity. As you have seen in your physics course, if you have taken any physics, when you see the curve resembling the alternate current, you will see that the curve resembles a square curve, which is shown right here. Now, this square curve, if you plot the current versus time, then you will see that the current changes direction to positive negative in a very fast interval. This type of relationship can be represented using a sine or cosine functions. Now, one thing you have to remember that these sinusoidal relationships are not just for sine and cosine. If you combine sine and cosine together, you are going to get another type of relationship which is also sinusoidal, since if you plot it, you are going to get the curve which is very similar to sine or a cosine function. In the first example, we are supposed to plot the graph of y equals sine x. The table of value is given here, which you have to fill it up, and then the graph is given at the bottom. So we are going to start with the major points, 0, 30, 45, 60. These, if you remember, are the special angles that you learned in the previous unit. When x is 0, we know that sine 0 is 0, and the decimal value is 0. When x is 30, the sine value is 1 over 2, which is 0.5. When x is 45, the sine value is square root of 2 over 2, which is about 0.7. When x is 60, it's square root of 3 over 2, which is about 0.9. When x is 90, sine 90 is 1. The decimal value is 1. When x is 120, we know that the angle goes into the second quadrant, sine is positive. Now, the reference angle for 120 is going to be 60, because 180 minus 120 is 60. Sine 60, we know, is going to be square root of 3 over 2, which the decimal value is 0.7. 135 again goes into the second quadrant, sine is positive. The reference angle is 180 minus 135, which is 45. So this is square root of 2 over 2. Now square root of 2 over 2 is 0.7 approximately. Then 150 again in second quadrant, so it's positive. 180 minus 150 is 30, so reference is 30. And we know that sine 30 is 1 over 2, which is 0.5. And 180 is going to be, again, is second quadrant, which is going to be positive, but 180 minus 180 is 0, so sine 0 is going to be 0, and this is 0. Now, one thing I have to fix here is that sine 120 square root of 3 over 2, which is 0.9. Now to continue with the table of values, 210 is going to be in the third quadrant, so sine is negative. Everything from now on to 360 is going to be negative, because sine in quadrant 2 and 3 and 4 are going to be negative. So 210 is going to be in third quadrant. The reference angle is 180 plus 30, which is going to be 30 degrees. So sine 30 is 1 over 2. So this is negative 1 over 2, which is negative 0.5. 225, the reference angle is 180 plus 45 is 45 degrees, which is square root of 2 over 2. Sine 45 is square root of 2 over 2, but it's negative because it's the third quadrant, so it's going to be negative 0.7. 240 is going to be 180 plus 60. Square root of 60 is square root of sine of 60 is square root of 3 over 2. So this is negative square root of 3 over 2, which is negative 0.9, about 0.9. 270 is going to be 180 plus 90. Sine 90 is 1, so this is going to be negative 1. 300 is going to be in the fourth quadrant, which is 360 minus 60. So the reference is 60 degrees. Sine 60 is square root of 3 over 2. So this is going to be negative square root of 3 over 2, which is negative 0.9. 315 is 360 minus 45. So reference is 45 degrees, square root of 2 over 2. But since it's in the fourth quadrant, is negative square root of 2 over 2, which is negative 0.7. 330 is going to be 360 minus 30. Sine 30 is 1 over 2, so this is going to be negative 1 over 2, which is negative 0.5. And 360 is 360 minus 360, which is going to be 360 minus 0. And sine 0 is 0, so this is going to be 0. Now we are going to plot individual points. Starting from angle 0, the value is 0, so we are going to have a point here. When x is 30, it's 0.5. So if we assume this is 1, this is negative 1. 0.5 is going to be right around here. Then if x is 45, then the value is 0.7, so 45 is about here. So 0.7 is going to be somewhere around here, approximately. And if x is 60, y is 0.9, which is going to be somewhere around here. And if x is 90, y is going to be 1, which is around there. Now we are going to go to 120. 120 is 0.9, so this is 120. 0.9 is going to be somewhere around here. Then 135, which is going to be right in between here, is 0.7, which is going to be somewhere around here. 150 is going to be 0.5, which is going to be here. And 180 is going to be 0. Now, if we continue, we are going to duplicate the same curve that we have so far. So this means that 270, if you look at the table, is going to be negative 1, which is going to be here. And 360 is going to be here. And the intermediate points are going to be exactly the same thing. So we're going to get a curve like the following. This is the curve of a base function for sines, y equals sine x. As you can see from the graph, the period is 360 degrees. The function is going to be increasing from 0 to 90 and from 270 to 360, and also the function is decreasing from 90 to 270 degrees. The domain of the function is x in R, and x is between 0 and 360 for this graph, and the range is y in R and y between 1 and -1. The next part of the question is asking what is the amplitude. The amplitude is 1 because the distance from the x-axis to the maximum or the minimum is 1 unit. The period is 360 degrees, or we can say the period is 2 pi. Pi is equal to 180 degrees, so 2 times 180 is 360. The x-intercepts are the points that the graph crosses the x-axis, and this was 0, 180, and 360. The minimum values are -1. For that one period that we drew, the minimum value was -1, and it occurs at 270 degrees. The maximum value is +1, and it occurs at x is equal to 90 degrees. The increasing interval, as I mentioned on the graph, the increasing is 0 to 90 and 270 to 360. So the increasing interval is 0 to 90 and 270 to 360. The decreasing interval was from 90 to 270 degrees. The domain was x in R for the period that we showed, and x less than or equal to 360, greater than or equal to 0. And the range was y in R, and y is less than or equal to 1, greater than or equal to -1. In the next example, we are going to plot y equal cosx. First, remember the special angles, 0, 30, 45, 60, and 90, and the values for the cos. Cos 0 is 1, so this decimal value is 1. Cos 30 is square root of 3 over 2, which is about 0.9. Cos 45 is square root of 2 over 2, which is about 0.7. Cos 60 is 1 over 2, which is 0.5. And cos 90 is 0. Now, we know that by the cast rule, cos is positive only in fourth and first quadrant. So the second and the third quadrant, cos is going to repeat itself, but with negative values. Now 120 is going to be 180 minus 60, so the reference is 60 degrees. Cos 60 is 1 over 2, so this means that because it's in the second quadrant, it's going to be -1 over 2. So this is -0.5. 135 is 180 minus 45, so the reference is 45. Cos in the second quadrant is negative, so it's going to be negative square root of 2 over 2, which is -0.7. 150 is 180 minus 30, so the reference is 30, so it's going to be negative square root of 3 over 2, which is -0.9. And 180 is 180 minus 180, so the reference is 0. Cos 0 is 1, so this is going to be -1. Now we go to the second part. The second part is 210, which is going to be in third quadrant. The reference angle is 30 degrees. Cos 30 is square root of 3 over 2. So this is negative square root of 3 over 2, which is negative 0.9. 225 is 180 plus 45. So the reference is 45. Cos 45 square root of 2 over 2. This is the third quadrant, so it's negative. So negative square root of 2 over 2, which is about negative 0.7. 240 is 180 plus 60. Cos 60 is 1 over 2. Again, third quadrant, so it's negative. 270 is 180 plus 90. Cos 90 is 0, so this is 0. Now we are in the fourth quadrant, so everything is positive. 300 is 360 minus 60, which is the reference is 60, so cos 60 is 1 over 2, so this is 1 over 2, 0.5. 315 is 360 minus 45, so cos 45 square root of 2 over 2 is positive because in the fourth quadrant, so this is 0.7. 330 is 360 minus 30. Cos 30 is square root of 3 over 2, so this is about 0.7. And 360 is going to be 360 minus 0, so 0 is the reference angle, cos 0 is 1, so this is going to be 1. Now we are going to plot the points. First of all, we are going to set this point to be 1 and this point to be negative 1. Remember that every unit on the x-axis is 30 degrees, so cos 0 is 1. Cos 30 was about 0.9, which is going to be somewhere around here. Cos 45 was about 0.7. This is 45 here, so it's going to be around somewhere around here. Cos 60 was 0.5, which is going to be here. Cos 90 was 0, which is here. Now, as I mentioned before, we are not going to plot every single point as long as we know the pattern of a graph of a y equal cos x. We know that cos 180 is going to be negative 1, so it's going to be here. Cos 270, based on the table of value, is going to be 0. And cos 360 was 1. Now every intermediate point in between you can plot it, but it's going to be on the same curve. The curve for y equal cos x is going to look something like this curve. Now again, if you look at this curve, you can see that the maximum value occurs at x equal to 0 and x equal to 360. The minimum value, negative 1, occurs at 180. The x-intercepts are 90 and 270. The function is decreasing from 0 to 180 and increasing from 180 to 360. The domain for this one period of the function is x in R and x between 0 and 360, and the range is y in R and y between 1 and negative 1. The period of the function is 360 degrees. Now, the amplitude of the function is 1. Again, the reason is that from the x-axis to the maximum is 1 unit, or to the minimum is 1 unit. The period is 360 degrees. The x-intercepts are at 90 degrees and 270 degrees. The minimum value we found from the graph is -1, and it happens at 180 degrees. The maximum value is 1, and it happens at 0 and 360 degrees. The increasing interval, as we found from the graph, is from 180 to 360 degrees, and the decreasing interval was from 0 to 180 degrees, because it starts from 1 and it goes to -1. The domain, we found that it's x in R, and x is between 360 degrees and 0, and the range was y in R, and y is between 1 and -1. In the next example, we have to find the points x representing the point of intersection of the graph of y equals sine x and y equals cosx between 0 and 360. If you recall from previous examples, the sine x looks something like this one from 0 and 360. And the interesting part about cos and sine graph was that whenever sine is 0, cos is maximum or minimum, doesn't matter. And whenever cos is 0, sine is maximum or minimum. So this means that when sine is 0 here, cos is maximum. When sine is maximum here, cos is 0. When sine is 0 here, cos is going to be maximum, a minimum in this case, here. When sine is negative here, but it's minimal, cos is going to be 0. And when sine is 0 here, cos is going to be maximum. So cos is going to look like this graph. In this example, we have to find these point of intersection, the x values here. Since the y values of this point of intersection is the same for cos and sine, this means that we have to solve sine x is equal to cos x. To solve this one, I'm going to divide both sides by cos x. From here I get sine over cos from previous unit is equal to tan x is equal to 1. Now, I have to solve this one using either my calculator or using the special angles. Remember the special angles? For angle 45 degrees, tan is 1. So from here I get the reference angle is 45 degrees. But using the cast rule, we know that the tan is also positive in the third quadrant, where x and y are negative, cos and sine are negative. So this means that knowing the reference angle, the other angle, which is going to be, so if I call x1 here, x2 is going to be 180 plus 45, which is 225 degrees. This means that when the angle is 45 degrees and 225 degrees, sine and cos of those two angles, they are going to be the same. And it is true because sine 45 is square root of 2 over 2, cos 45 is square root of 2 over 2, and sine 225 is negative square root of 2 over 2, and cos 225 is negative square root of 2 over 2. In the next example, we are supposed to find x-coordinate where the graph of y equals sine x will intersect the x-axis. Again, if we draw the rough graph of a y equals sine x, we get a curve like this one. We have to find these points. Now we know that we want to find the x-intercepts here. So this means y is equal to 0. So we have to solve sine x is equal to 0. From the special angles, we know that when x is equal to 0, sine x is 0. So this is this point. For this point, we know that there is another angle which is x is equal to 180 degrees, where sine is 0. The next one is this one, which is x is equal to 360 degrees. So the three angles that make y equal sine x equal to 0 or cross the x-axis are 0, 180, and 360 degrees. The next example says write an expression involving the integer n that will generate all the x-intercepts for the function when the values for n are substituted into the expression. For the first three, we found that these values from the previous example were x is equal to 0, 180, 360. I can write this one as 0, 180 times 1, 180 times 2, and since the sine curve repeats itself in the negative or positive values, I can also write negative 1 times 180, negative 2 times 180, and so forth. So if you look at this pattern, I can write that the values are 180 times n, where n can be either 0, plus or minus 1, plus or minus 2, and so forth. Now it's asking use the expression that we found previously and substitute the values n equal to 4, 5, and 6. So the values, they become x is equal to, let's say x4 is 180 times 4, which is going to be 720. For 5, we say x5 is going to be 180 times 5, which is 900. And the last one for 6 is going to be 100 times 6, which is going to be equal to 1080. The next example is saying consider the function y equals sine x minus cosx. Predict the y-intercept of the function. By definition, y-intercept is when x is equal to 0. So we are going to say y is equal to sine 0 minus cos 0. Now, by definition, sine 0 is 0 minus cos 0. Cos 0 is 1, so it's going to be 0 minus 1, which is negative 1. So we can predict the y-intercept of this function is negative 1. The next part of the question says predict the x-intercepts of the function from 0 to 360. By definition, x-intercepts are when y is equal to 0, so we have to solve sine x minus cos x is equal to 0. If we move cos x to the right, we get sine x is equal to be cos x divided by cos x both sides. We get this one 1, so we get tan x is equal to 1. From 0 and 360, we know that tan x is 1 for x is equal to 45 degrees, and 180 plus 45, which is 225 degrees. So the x-intercepts are 45 degrees and 225 degrees. The question, next one, is explain why your answers in part B can be found by solving tan x is equal to 1. Because we are dealing with the x-intercepts, y has to be 0, and then if we move cos x to the right, we get that tan x has to be equal to 1. So we are in fact solving tan x equal to 1, which produce the x-intercepts equal to 45 and 225 degrees. The next example asks us to graph the function for the interval of 0 to 360. The function is y equals sine x minus cos x. So I'm going to use the main points here. The main points are 0, 45, 90, 135, 180, 225, 270. For x equal to 0, we know that sine is 0, so sine 0 minus cos 0 is 1, so it's negative 1. For 45, we get that sine 45 is square root of 2 minus cos 45 square root of 2 over 2, so this is 0. For 90, sine 90 is 1, cos is 0, so this is 1. For 135, sine 35 minus cos 35, if you use your calculator, it becomes 1.4. For 180, sine 180 is going to give you 0, but cos 180 is negative 1, but you have negative cos x, so it's going to be positive 1. For 225, sine 225 is going to be negative square root of 2 over 2. Cos 225 is negative square root of 2 over 2, but there is a negative here between sine and cos, so it's going to be square root of 2 minus square root of 2, which is going to be 0. And 270, sine 270 is negative 1, cos 270 is 0, so it's going to be negative 1. Now, if we draw our x and y coordinate system, let's say this is 1, this is negative 1, this is, let's say, 90, 180, and 270. Then we have x equal to 0 is negative 1 here. When x is 45, y is 0, which is here. When x is 90, y is 1, which is here. When x is 135, in between 90 and 180, it's 1.4, which is going to be somewhere around here. When x is 180, it's going to be 1, which is here. When it's 225, which is going to be 0 here, and it's 270 is going to be negative 1. So we are going to have a curve like this one. This is part of our graph in the interval of 0 and 360. But to finish the interval, we also have to have the value to 360, which you can do it yourself if you want. In the next example, we have a Ferris wheel. The wheel has a radius of 8 meters. So this is your Ferris wheel. We know that this radius is 8 meters. And it turns counterclockwise, so it goes this way. We have to plot two different types of graphs, but in each one of them, we are supposed to assume the radius from the center of the wheel to your car is along the positive x-axis. So if this is our x and y coordinate system, the radius is right on the positive x-axis. The first one, we have to sketch the graph of the horizontal displacement versus the angle through which you turn for one rotation of the wheel. This means that if the wheel turns one rotation, meaning if it starts from A, it goes to B, then it goes to C, then it goes to D, and then it goes back to A. How the graph looks like. Now, roughly, this is going to be my graph. This is going to be the angle theta, which the radius makes with the positive x-axis, so angle theta is here. Now we are going to plot the distance, the horizontal distance of the car versus the angle through which you turn one rotation. So when theta is 0, this means that A is here on the positive x-axis. Then we can see that the distance is 8 meters, which is here. So when theta is 0, the distance is 8 meters. Let's put this one to be 8 and this one to be negative 8. Negative 8. When theta is 90 degrees, you can see that the horizontal distance is 0. So when it's 90, the horizontal distance is 0, which is here. So this is your 90 degrees. When theta is 180, meaning this angle, so we are at point C, the distance is negative 8 now. So it's going to be 180 is going to be negative 8. When the angle is 270, which is this angle, we are at point D, the distance is going to be 0. So 270 is going to be 0, this point. And when it goes one complete rotation and it gets back to A again, then the distance is 8 meters. So it's going to be somewhere around here. So our graph looks something like this one. Now, which function models a horizontal displacement? You can see that this one resembles a cosine function. Now, to prove this one, we can easily write the relationship between the horizontal distance and the angle. If we look at this triangle, this is a right triangle. We are looking at this distance here. This is the horizontal distance. And this is angle theta. So I can write in this right triangle that cos theta is adjacent, which is x, over radius, which is 8. So I get x is 8 cos theta. And if you plot this one, you get exactly the same graph which is shown here. So the relationship is the horizontal distance is related to the angle through the cos function. The next part of the question says, sketch the graph of your vertical displacement versus the angle through which you turn one rotation, and also which function models this relationship. Now, let's say the angle is theta, again the same idea, this is theta. When theta is 0, meaning that you are at point A, the vertical distance is 0, so you're going to get this point. When you go to B, the angle is 90 degrees and the vertical distance is going to be 8, which is this distance. When you are at point C, the angle is 180, but the vertical distance is going to be 0. When you are at D, the angle is 270 degrees, but the vertical distance now is negative, so it's going to be negative 8. And when you turn one complete rotation, the angle is 360, but the vertical distance now becomes 0. So the curve, which looks like this, resembles a sine function. Now, we can do the same thing as before. We can look at the triangle, a right triangle like this one. Since we are looking for this side, the vertical distance, I can write that sine theta is opposite, which is y, over radius, which is 8. So from here I get y is 8 sine theta, and you can see that the relationship between y and angle is through a sine function.